So welcome my dear students. My name is Ankit Pandey and today we are going to discuss about the chapter that is trigonometry. Okay. So first of all we will talk about the importance of this chapter, why we study this chapter and what is the requirement of this chapter in our day-to-day life and where we can use trigonometry. Okay. So first of all, if I talk about trigonometry, what is a trigonometry? So basically trigonometry is a study of right angle triangle in which we find relationship between the angles and the ratio of their side. So suppose if we have any right angle triangle, suppose I am drawing a right angle triangle A, B, C, right angle at B. Okay, so let us first discuss the parts of this triangle. Okay. Before starting the chapter, we will study some of the basic things about a right angle triangle. Here, this BC is called base. BC is called the base of the triangle onto which the triangle stands. Next, we have this AB. It is known as perpendicular. Okay, this is perpendicular, and sometimes it is also known as height. Next we have this AC. So what is this AC? AC is the hypotenuse. It is the hypotenuse of the right angle triangle. So basically in a right angle triangle we have these three parts. BC, that is base, AB is perpendicular and height, and AC is the hypotenuse. Now in any right angle triangle we know that the hypotenuse is the longest side. Okay, this is the longest side, and we are studying about trigonometry. So we will be taking relationship between the ratio of these sides and an angle. So first of all, we have to mention some angles in the right angle triangle also. So let us name this angle C as theta. Okay, so this is the angle theta. So basically in trigonometry we will be studying about relationship between the ratio of the sides and the angle. And if I talk about where this trigonometry can be used, so like if I give an example, to measure the height of a mountain or measure the height at which a plane is flying. So is it able for us to physically measure that particular length? No. If I ask you that this is a mountain and we have to find its height, or this is a bird, suppose this is a bird, and I have to find at which height it is being flying from the ground. So practically this is not measurable physically, okay, but we can find this height using trigonometry. So trigonometry basically is a branch of mathematics which deals with the height and distance, and moreover trigonometry is applied on the right angle triangle. Okay, so basically all this trigonometry will be helpful in finding the sides or the angles or any height and distance. Okay, so this is the introduction about trigonometry. Now let us start the first thing which we are going to study in trigonometry, that is trigonometric ratios. Okay, trigonometric ratios. So now let us start. Trigonometric ratios. So this is the first topic that we are going to study in trigonometry. So basically what is a trigonometric ratio? So let us draw the triangle, rectangle, sorry, yes, triangle, one more time. Okay, so this is the required right angle triangle, which is right angle B. Now we have this ratio. This BC is base, this is height, and this is hypotenuse, as we have already discussed. So with these sides, what ratio can be driven? What ratio I can write with the help of these three sides? So the first ratio I can write is, I can write it height upon hypotenuse. I can write the first ratio, that is AB upon AC. This is the first ratio. Next ratio what can be written? That is base upon hypotenuse, BC upon AC. So I can write BC upon AC. And next is height upon base, that is AB upon BC. Okay. So with the help of these three sides, I can write these three ratios. So can we have any other ratios also? Yes, we have three more ratios if I reciprocal all this. So if I reciprocal all this, so we have three more ratios, that is AC upon AB. Next is AC upon BC, and then we have BC upon AB. Okay, so these are six ratios which can be find out in any right angle triangle ABC. Okay, now this six ratios have been given some name. Okay, so what are the name of these ratios and how we can find these? So let us write it more specifically. So these ratios are nothing but the first ratio is sine. The first ratio is sine. Second is cosecant. Second is cosecant. Third is tangent. Third is tangent. Fourth is we have sine, cos, tan, and then we will take reciprocal of sine, cos, and tan. So the reciprocal of sine becomes cosine. Okay. Next we have reciprocal of tangent, that is cotangent. And we have last secant. We have secant. So these are the six ratios which we are going to study in particular trigonometry. So what are the ratios? Sine, and then cosecant, tangent, cosine, cotangent, and secant. Now these are not always written in this form because writing it every time will take so much of time. So it is being written in short form. So sine becomes only sine, cosecant becomes cosec, and tangent becomes tan, cosine becomes cos, cotangent becomes cot, and secant becomes sec. So basically we take only first three alphabet, but here in cosecant we take 5 because for cosecant or secant cosine, okay, the things are remaining same. So that is why for cosecant we are taking 5 alphabets of cosine. So now we have this 6 trigonometric ratio, that is sine, cosec, tan, cos, cot, and sec. So we will be discussing only these 6 special ratios for any triangle. Now what are these ratios? So if I relate the ratio that we have written before and with these trigonometric ratios, so I can write that sine is equal to the height upon hypotenuse for any right angle triangle. Sine is just the ratio of height and hypotenuse. So what can I write? At the place of sine, I can write AB upon AC. So sine is equal to AB upon AC. Now, what is this cosec? Cosec is just the reciprocal of sine. Like we taken the reciprocal of the ratios. So if I take the reciprocal of sine, that becomes cosec. So cosec is equal to what? Reciprocal of sine, that becomes AC upon AB. Next we have tan. So tan is just equal to the reciprocal of height, ratio of height and base. So that can be taken as AB upon BC. Okay. So we have these three ratios. Now we have cos. So cos is equal to base upon hypotenuse for any right angle triangle. And one more thing, when we are studying about height, base and hypotenuse, we have to take an angle. So all these are just to the respect of any angle. So if I take theta here, so according to this theta, this BC becomes the base and this AB becomes the height and AC becomes the hypotenuse. But anyhow, if I change the angle here, if I take A to be the reference angle, the things will get changed now. If I take A as an angle, what is being height here will be now base. So this base, height and hypotenuse is relevant to this theta. So I am writing all these ratios with the respect of angle theta. Okay. So tan becomes ratio of height and base, that is AB upon BC. Now we have cos. So cos is equal to base upon hypotenuse. So what can I write? I will write BC upon AC is the cos. And now cot. So cot is just reciprocal of tan. Cos, this cot is simply reciprocal of tan. So that will become BC upon AB. Okay. Now we have this sec. So sec is just the reciprocal of cos. Sec is reciprocal of cos. So I will write it as AB upon BC. Okay. So these are the 6 ratios that we are going to study in this chapter. These are the only 6 special ratios. Okay. So we have sine, cosec, tan, cos, or tan, sec. So this is the only 6 ratios that is important for any right angle triangle. Now, how can I remember all these ratios? For you, when you are learning this first time, this will be like a little bit complicated to learn all these ratios. What is AB upon AC called? What is AB upon BC is called? What is BC upon AB is called? So we have these 6 ratios and 6 names of the ratio. So you must get confused sometime. So I will take you a short trick to remember all these ratios first. Okay. So let us now study about the short trick ratio that we can learn it easily, remember it easily. Okay. So what is the short trick? So short trick to remember all the ratios. See, basically what I will do, I will write sine, cos, tan. Okay, these are the basic ratios, sine, cos, and tan. Next we have reciprocal of sine, that is cosec, reciprocal of cos, that will be sec, and reciprocal of tan, that will be cos. Okay, so I have written all 6 ratios in this manner: sine, cos, tan, and below sine reciprocal of sine, that is cosec, below cos reciprocal of cos, that is sec, and below tan we have reciprocal of tan, that is cot. Simply now I will put this sine here. Now for sine. Sine is what? Sine is basically, we have to remember only sine or either cos. The 2 ratios, if it is learned, then all the 6 ratios can be automatically remembered. See, the sine was, that is height upon hypotenuse, so that will be AB upon BC. Now cos, that is BC upon base upon hypotenuse, that will be BC upon AC. So that becomes BC upon AC. And now we have tan, that is height upon base, that will be AB upon BC. So you have to only remember sine, cos, and then cosec, sec, what will automatically be remembered. So from sine, if I am going down, for sine we are going AB upon AC. So for cosec we will go up, that is AC upon AB. For cos BC upon AC, and sec AC upon BC. For tan AB upon BC, and for cot we will go upon, that is BC upon AB. So this is the short trick to remember all the ratios. Okay, so let me put this in a box. This is the only short method to learn all the ratios. So basically, if you remember sine, cos and tan, then cosec, sec, cot will automatically be remembered. So this is the short trick in which we can learn all these ratios easily. Okay, is it clear to everyone? Okay, then let's move ahead. Now, here comes the value of trigonometric ratios at specific angles. Okay, we will do some questions on basis of trigonometric ratios. First of all, let me give you a brief introduction about the ratio value of the trigonometric ratios at some specific angles. Okay, so what are the specific angles here that we will be studying? That okay, so we will be studying about values of trigonometric ratio at specific angles. See, here angles can be from the theta can vary from 0 to 360 degree. Okay, so this all trigonometric ratios take some values at angle from 0 to 360 degree. But we are going to study about some only specific angles here. So what are the specific angles? What can be the value of theta? So theta will start from 0 degree and then 30, 45, then we have 60 degree and then 90 degree. So we will be studying the value of trigonometric ratios at only these angles. That is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Okay. Now what is the value of, if I take all the ratios, that is sine, cos, tan, and then we have cosec, sec and cot. What are the values of these ratios at these angles? So let me take a table here. Okay. So these are the tables for value of all the trigonometric 6 ratios at the specific angles. Now, if I start from sine, what is the value of sine 0? What is the value of sine 0? Let me first write all the values and then I will make you understand how all these ratios takes up the value at different angles. So the value of sine 0, that will be 0. Okay, sine 0 is nothing but 0. And then we have sine 30. So sine 30 is equal to 1 by 2. Sine 30 is equal to 1 upon 2. And then sine 45 we have 1 by 2. Sine 60, that is root 3 by 2. And then we have sine 90, that is 1. Okay, so basically we have sine 0, that is 0, sine 30 1 by 2, sine 5 1 by 2, and then sine 60 root 3 by 2, and sine 90 1. So for remembering all these ratios, we just have to remember the sign. Okay, if the value of sine 0, sine 30, sine 45, is done, then all the ratios can be found automatically. So basically we have here 1, 2, 3, 4, 5 angles at 6. That is 30 values. For out of 30 values, we have to learn only 5 values, and then all the other values will be automatically remembered. Okay. So if I have written sine 0, sine 30, then how will I write the cos? See, sine and cos are complementary. Sine and cos are complementary ratios. I will tell this what is a complementary ratios. First of all, let me complete the table. Okay, so sine and cos are complementary means sine of A, that will be equal to what? That will be cos of 90 minus A. Okay, sine of A is equal to cos of 90 minus A because these are complementary. So if I have to find sine 0, so sine 0 will be equal to cos 90. If I have to find cos 0, then that will be equal to sine of 90. So cos 0 will be sine 90. That is, I am starting from 1. So this value of cos is just the reverse of the sine. So how will I write it? 1 and then 3 by 2 and then 1 by 2 and then we have 1 by 2 and then 1 upon 0. That will be 0. Okay. So this is what? This is the value of cos. So cos always takes up the reverse of the value of sine because sine and cos are complementary. Okay. So sine 0 is equal to cos 90. Sine 30 is equal to cos 60. So wherever this A and 90 minus A is complementary, so sine A will be equal to cos of 90 minus A. Now, as we have find the value of sine and then cos, now for us it is very easy to find the tan because we have already known that tan is equal to what? Sine upon cos. So tan is equal to sine upon cos. So we will find the value of tan just by taking the ratio of sine and cos. So tan 0 will be equal to sine 0 upon cos 0. That is 0 upon 1. 0 upon 1 is nothing but 0. Now we have tan 30. That is sine 30 upon cos 30. So that will become 1 upon 3. And tan 45, that is sine 45 upon cos 45. So 1 upon 2 upon 1 upon 2, that will be 1. Again, sine 60, root 3 upon 2 by 1 upon 2, so that will be root 3. And now tan 90, that becomes 1 upon 0. So here we have 1 upon 0, that will be infinite or can be said as not defined. So let us write tan 90, that is not defined. So these are the values of sine, cos, tan at some specific angles. Now, if I have to write the value of cosec, so I will simply take the reciprocal of sine. For cosec, we will take the reciprocal of sine. So cosec 0 will be 1 upon sine 0. So 1 upon sine 0 means 1 upon 0. So 1 upon 0 is again not defined. Okay, again it is not defined. Now we have this cosec 30, that will be reciprocal of sine 30. So reciprocal of 1 by 2 is nothing but 2. So we will keep on taking the reciprocals. So cos 45, that is reciprocal of sine 45. So that will root 2. Again reciprocal of root 3 by 2, that is 2 by root 3. And then reciprocal of 1, that becomes again 1. Now we have sec. So sec is nothing but the reciprocal of cos. So I will take sec 0 is equal to reciprocal of cos 0, that is 1 by 1. So that becomes 1. Now again reciprocal of root 3 by 2, that will be 2 by root 3. And then we have reciprocal of 1 by root 2, that is root 2. Reciprocal of 1 by 2, that is 2. And then reciprocal of 0, that is 1 upon 0. Again it will be not defined. Okay, now we have cot. So cot is basically reciprocal Now we have got 30, that is reciprocal of tan 30, so it will become 2, 3. Again we have reciprocal of 1, so 1, reciprocal of root 3, that is 1 upon root 3, and then we have reciprocal of tan 90. So that was become 1 upon 0, it was 1 upon 0, so 0 upon 1, it becomes again 0. So these are some basic trigonometric values at some specific angles. Okay, so these are the values of sin, cos, tan, cos, sec, cot at different angles. Now we will be utilizing all these values in finding the length or the height of any object we want to find. So suppose, let us remove this first. Okay, so now all these things that we have studied about trigonometric ratios and value of trigonometric ratios at different angles, how we gonna utilize this? So suppose I give you a question here that we have an aeroplane. Okay, we have an aeroplane flying. Suppose this is a plane that is flying at some height on the ground. This is the ground. So this is the plane flying, and we want to find the height at which the plane is flying. Okay. So suppose this is point A and this is point B, and we want to find the height of AB. What is the height of AB? And the observer is at point this. How we gonna find the length or the distance of this AB? For that, we have two things to study. We have two things to study before going on to this, and that is the first is angle of elevation, and second is angle of depression. So what is the meaning of angle of elevation and angle of depression? What does it mean? So if I have to find the height of this plane, so we have to form a triangle first, because we are studying about trigonometric ratios, and trigonometric ratios is applied on right angle triangle. So we have to form a triangle consisting of this length AB. So suppose I am observing this plane from here, and I am just flat on the ground, seeing from this point. So it's the line joining the tip of the plane and my eyesight. This is what? This is the eyesight line. Okay, so this line is making an angle theta with the ground. So this theta is nothing but angle of elevation. So what is the angle of elevation? If suppose there is a person who is observing anything which is just above his eyesight, above this eye line. So suppose this is the line of sight, and it is observing anything which is just above the head. So the angle it formed, the line of sight, the angle between the line of sight and the horizontal is the angle of elevation. Okay, so angle of elevation means whenever we are seeing something up, my head is just like this in this orientation. Okay, so I am seeing something that is up above my head, and the angle which my line sight makes with the horizontal is known as the angle of elevation. So angle of elevation is nothing but the angle of line sight and the horizontal, and it is always up above the head whenever we are something just above our head. Now what is angle of elevation? So suppose I am, let me erase this. So suppose I am at a building, Suppose I am at a building, standing there at a terrace, and I am seeing a child here. I am seeing a child here down from the building. So the line of sight which joins the head of this boy, this line of sight and the horizontal and the angle made between these, this is known as angle of depression. This is what? Angle of depression. So depression is something that which we are observing anything or which we are seeing everything just below our eyesight. Okay, if we are seeing something just down the level, okay, down the level of head, so that means we are seeing at an angle of depression. So if we are viewing or observing anything which is just below our line of sight, eyesight, or the height at which the eyes are maintained, so this is what? This is known as angle of depression. So this is angle of elevation and this is angle of depression. Both are the same thing. Okay, both are the same thing, but orientation are different. In angle of elevation, we are saying upward, and in angle of depression, we are saying downward. But the angle here is always with the line of sight and the horizontal. So always remember this angle is made with the horizontal, not the vertical. So angle made by line of sight and the horizontal. Here also the angle made by line of sight and the horizontal. So this is the angle of elevation and angle of depression. Now to find out the distance of this plane at which it is being flying, what we need to know? We have to find this AB. So let us suppose it be x. So finding the value of this x, we must know the any other two sides of the triangle. So suppose this is, we made a right angle triangle A, B and C. Okay, so this is a triangle A, B and C. We need to find this AB. How can we find? So I can use the value of theta. Okay, so if I use any trigonometric ratios, suppose I am using sin theta. So sin theta is what? That is perpendicular upon hypotenuse. So x upon this AC. Okay, so if theta is known, suppose theta is 30 degree. So theta is equal to 30 degree. So what I write? I write sine of 30, that will be what? X upon AC. Now we have two unknown things. Sin 30 we know that it will be equal to 1 by 2, as we have already discussed the value of trigonometric ratios at different angles. So sin 30 will be equal to x upon AC. Now to find this x, we must know AC. So for any right angle triangle, if we have to find any side and if any other two sides is being known, we can simply find this AC. So let us suppose this distance AC is 1000 meter. Okay, if I get to know that this AC is 1000 meter, so what I will do? I will put this AC is equal to 1000. Now we know that sin 30 is 1 by 2. This x is needed to be found, and AC is 1000. So from here I can say that x is equal to 1000 upon 2. That will be equal to 500. See how it was easy. Okay, we find the distance at which the plane is flying simply by knowing the any one side of the right angle triangle that it is being making. Okay, so what if I say that this AC is unknown? This AC is unknown. So now we have to find this BC. If I say that we don't know the length of AC, so how we gonna find out? So we will use some other ratio. So if I say the distance of this point B from the observer is suppose 500 meter. So now how will I find? So when AC was known, I was using sin 30. Now what is being known? BC is a known thing and we have AB to find. So what trigonometric ratio will be using, if I have this BC and X. So what is this X? This is the perpendicular. This BC is what? This is base. So what was the ratio containing perpendicular and base? Yes, that was tan. So I can write tan theta is tan theta will be equal to what? X upon this BC, that is 500. Now theta is known, that is 30 degree. So I can write tan 30 is equals to X upon 500. Now we have already discussed the value of tan 30. That was 1 upon root 3. So that is 1 upon root 3 is equals to X upon 500. Okay. So now from here X can be calculated as 500 upon root 3. Rationalizing it, we have 500 root 3 upon 3 meter. So when this base was known, I was using tan. So basically, if we have to find any length, any distance, we will form a triangle, and then we will try to find any one thing that is known, and next we have some unknown, and we will use some trigonometric ratios to establish the relationship between the two sides. So here it was perpendicular and base, so we know that the ratio of perpendicular and base is nothing but tan. So I am using tan 30. So this is the method of utilization of trigonometric ratios. Okay. So this is the I think end of the today's class. Now we will do some questions in the next class on the basis of trigonometric ratios and